Topic 2. So the Earth itself is a living planet. When we're talking about ecology, we're talking about the interactions among organisms and other organisms and their actual physical environment. So the Earth is a biosphere. Anything that holds life is part of that biosphere. Now, ecology, because you guys need to understand this properly, is the interaction between organisms and their environment. Now, we'll talk about actual food chains and food webs later on, but it's important that you guys understand that the main reason for the study of organisms' interactions and their environments is so that we can understand what is going on with the planet. So if something's wrong with the krill, it's going to throw this whole thing off balance. Okay, the levels of organization. You have an individual organism, so one of you guys. Population, a group of individuals that belong to the same species and live in the same area. For the sake of a school example, if you're an 8th grader, 8th graders are your population. If you're a ninth grader, ninth graders are your population. The community is where all the different populations live in a defined area. So for our school example, it would be the school. The ecosystem would be where they all live together with their physical environment. So all of Hialeah, I guess. Now, if you need an actual physical, or I guess visual example, I'll show you guys that now. A biome, it's basically a group of ecosystems, but they're all in the same climate. So alright, so just so you guys can actually see what I'm talking about, here's the individual fish, the population of fish, or the school of fish, the community with new organisms, the ecosystem, all organisms in that area, the biome, all environments in one specific climate, and then the biosphere, which, like I said, is everything that can support life. So the actual biomes, here's an example, has all the biomes. We're not going to focus too much on this. You should know some of them, and we're probably going to do at least one worksheet that goes over them, but we're not too worried about them right now. Alright, biotic and abiotic factors. You guys should be somewhat familiar with this. Alright, so if I'm asking you what the weather is, usually I'm like, nice weather we're having today. Today being the key word. It is a day-to-day condition. Now, climate is different. If I'm asking you for the climate of Florida, all of you guys are going to say hot. But if it's raining today, the weather today is rainy, the climate as a whole is hot. Now, there are certain places that may have a slight different climate. Those are going to be microclimates. So I'll give you guys an example. I went to FIU for college. Now, don't let this picture fool you. It was always raining. But when I left FIU, and I'm not talking about like I was 3 miles out, I mean like literally I was at the exit of FIU, it was sunny. So FIU as a whole, if you ask anyone, it is always raining. They have a rainy microclimate. Alright, so a niche. It's pronounced niche, not Nietzsche, not Nice. Niche. A niche is a range of physical and biological conditions in which a species lives in a way to obtain what it needs to survive and reproduce. We'll go more into detail a little bit later. Just hold on to that thought. All you need to know right now is it has to do with the physical and biological conditions for an organism to properly thrive. So, tolerance. Now, an organism has a set of conditions. If you've ever owned a fish and the tank got too cold or too hot, then you know that a certain organism has a specific tolerance. If they cannot handle it, they either move on or they just die. So we see this a lot when we're studying actual populations. In the actual scientific world, there are actually papers stating that many organisms, because their set environment is becoming too hot because of global warming, these organisms can no longer tolerate their environment, or there's not enough food, or there's not enough space because we basically built a Walmart on everything that we can find. So it's causing different populations to move about, and then that changes everything around them. Now, defining a niche. I told you guys, remember, it's pronounced niche. Do not confuse it with anything else. Alright, so like I said, a niche is basically how an organism interacts with biotic and abiotic factors. If I was a bird that only lived in Miami, let's say, and I thrived on the hot temperature climate to properly reproduce, I have all the trees I could find because, like, the 5 trees that we all left alone are just the types of trees that I can eat. That would be my niche. I have the food that I need, I have the water that I need, I have everything I could possibly need in order to properly thrive. That's basically what a niche is, a place in which the organism basically interacts with abiotic and biotic factors, and it allows the organism to gain fitness and basically live its best life. So the resources is basically going to be anything you need for life: water, nutrients, light, food, space. We're going to go over that again later in a different topic. Here's a small like cheat sheet so you guys can see the physical and biological aspects of a niche. Now, competition. If any of you guys have done online gaming with other players, or if you have a sibling, or if you've played any sports, you know what competition is. Basically, it's organisms trying to compete for limited resources. So, if I told you guys right now that in a class of 30, I'm only giving out 5 A's, you guys are going to want to be one of those 5 A's. And that is creating a competition amongst our small community, which is the classroom right now, for this example. Now, there's 5 A's, which means it's a limited resource, and you all want that because you want to make sure your parents don't kill you. That's basically what the competition is in the animal world. If there's not a lot of water, I need to make sure that I get it so that I can go on and reproduce. The key to biology, basically the way to win life in biology, is to reproduce at any cost. So animals will compete for food, mates, anything that they need in order to properly thrive. It can happen with the same species. So you guys are all students. It can happen with all of you. It can happen with other species. Um, Make sure you know the difference intra and inter. Please understand, intra, same species; inter, different. Make sure you know that distinction. It may be important later on when you maybe, I don't know, have a test. All right, predation, herbivory, and keystone species. So predator and prey populations, again, we'll focus on it later, but just so you guys have a small idea, if there is 5 predators and 3 prey, not everyone is going to eat, which means that it's going to control the population of prey, because there may not be prey after those 5 eat, or those 3 eat, because not all 5 are going to eat. But it's also going to change the number of predators, because the prey and predator population check each other off. So if there's not enough prey, eventually the predator population goes down, which allows the prey population to go up, and they just keep going up and down, up and down. And the same thing happens with herbivores. They do the same thing, but with plants. That's just exactly what I just went over. Same here. Okay, so your keystone species. Your keystone species is basically like the best species in your ecosystem. If something happened to this one specific ecosystem, everything would come crashing down. It's your most important player, I guess. So they give you an example right here. So urchins are herbivores whose favorite food is kelp, giant algae, and they grow in undersea forests. So if the urchin ended up decreasing, then that means the kelp and the giant algae would end up growing because they don't have the urchins to keep them in check. And that's going to cause a lot of issues, because if there's any other organisms, like any other plants that need to photosynthesize, they won't be able to get that actual sunlight in order to properly grow. For symbiosis, you guys can do that on your own time. Most of you guys know what it is. If you need help understanding symbiosis in this relationship, please come speak to me or Miss Yanes, depending on who you have. Alright, So you have primary and secondary succession. So this one is going to be a lot, and I may go off topic, and I apologize in advance. So primary succession. The way that primary succession works is basically you have a clean slate. Nothing has grown on this before, right? So it's nice, it's empty, there's nothing there. And then suddenly something shows up, whether it was brought here by the wind, a bird, it doesn't matter. Eventually something starts to grow. And this is called a pioneer species. And the pioneer species basically tells you guys what this is going to be. So if I gave you guys in a group of 4 a sheet of paper and I said, you guys need to draw something, but you cannot speak to each other. You just have to draw something and make sure it's cohesive. The first person to draw on that paper would be a pioneer species. And they're basically setting the tone for the rest of the picture. And that's exactly what the fungus is doing here. So secondary succession is different. When we're thinking secondary succession, something must have happened first to make it a clean slate. And it's not even a completely clean slate. You're still starting off with a couple of survivors. So we had Australia almost completely on fire, yes? If you look at the actual trail that the fire left behind, it's going to wipe out a majority of animals, a majority of plant life, but it's not going to wipe it all clean. This is one of the things that can happen that lead to secondary succession. Let's say this picture is like right at the end of the fire. There'll be trees here, trees here, trees here. Maybe they won't be as tall. Maybe there'll be little shrubs. Maybe this is what we're going to be looking at. But there will be a starting point. There will be no pioneer species here. Make sure you know the pioneer species is solely for primary succession. Now, it doesn't only have to be a natural disaster. More likely than not, it is. If I was to decide that for some reason I hated trees and I was going to chop them all off and sell them for firewood, I would be causing secondary succession because I might not need all those trees. Maybe some trees don't burn right. The main part of this is that if you wipe this forest out, whether it be a natural disaster or not, you will never get this forest back, at least not to what it used to be. When things start coming back, they may not be the original forest. It will never be the same forest that you started off with. The pros, though, are because unlike primary succession, it does have some plant life or organisms left, it comes back quicker because it had a starting point. They didn't have to wait for some random fungus to grow on a rock. Like I said, natural disturbances, wildfire, hurricanes, also from logging and farming. Look at this. Okay, conditions underwater. So underwater environments are a little different. You need specific things like the depth, temperature, flow, amount of dissolved nutrients, specifically dissolved oxygen more than anything though, because it does actually tell you whether or not things can properly grow in it. You need to make sure you have things to live, such as oxygen, nitrogen, potassium, phosphorus. We went over this. Dissolved substances. And threats to biodiversity, honestly, it's us. We're the threat to biodiversity. Anytime we do anything like pollution or hunting or overhunting specifically, altering habitats, like they wanted to build apartments in the Everglades because why not? That's going to change the environment, which isn't going to change the biodiversity, which is going to change everything and eventually lead to some form of climate change. Oh, that's it.